Alright guys, welcome back, and we're actually going to complete this example that we looked at on Saturday of last Tuesday when the class was rescheduled because we wanted to actually finish off properly by getting the information or the cumulative frequency curve done on a graph sheet. So remember the information here, it was about packages if you recall the last lesson. And the total number of packages would be the total frequency, which is 50, and that would be the last value here. And you remember we're plotting the upper class boundaries against the cumulative frequency, and of course to get the cumulative frequency to touch the x-axis, this one was incorporated as well. So we already did the rough sketch to it, which was this, if you can recall. And all we're going to do now is to get it done on graph sheet. So we're just going to put this away. So again, I hope you guys would have gotten your graph sheets by now. Just to reiterate that it's important to get yourself organized. All right, so remember the question says using a scale of 1 centimeter to represent 5 kilograms on the x-axis and a scale of 1 centimeter to represent 10 packages on the y-axis, draw a cumulative frequency curve to represent the data. Alright, so we're going to get into this right now to get it done on the graph sheet. Now this cumulative frequency is a little bit small. CXC wouldn't want you to necessarily have that small, but the important thing is that we're able to construct it properly. So what we're going to do now is just to get the numbering of each axis correct. So we're going to start with the x-axis. So using a scale of 1 centimeter to represent 5 kilograms on the x-axis. So the x-axis is weight. So for every 1 centimeter, we're going up by 5 kilograms. So 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay? So we're going up by 5 kilograms every 1 centimeter, so 5, 10, 15, 20, 25, 30, 35, 40, 45. All right, so that would have been the x-axis. All right, 1 centimeter represents 5 kilograms on the x-axis. Now for the y-axis, it says on a scale of 1 centimeter to represent 10 kilograms on the y-axis. All right, so for every 1 centimeter on the y-axis, which is this axis here, labeled as a cumulative frequency, also referred to as the number of packages. And I've tried to get the camera to come in a little bit closer to the page because I want to see those small lines on the graph sheet. So for every 1 centimeter, we're going up by 10 kilograms. All right. So again, the scale is incredibly important because it helps us to ensure that my pencil point broke, so I'm just replacing the pencil. So the scale ensures that it makes our life easier, so we have to follow the scale. So for every 10 centimeter, for every 1 centimeter, we're going to buy 10 packages. So 10, 20, 30, 40, 50. And the recommendation was for you to stop at 50. Now this is pretty small for a cumulative frequency curve, but that's fine. As long as you know to plot it, that's good. All right, CXC would like to extend it. Normally when I give you a question, I make sure that the cumulative frequency curve is larger on it, but that's fine. So for every 10 centimeter, we're going up by, for every 1 centimeter, we're going up by 10 packages, all right? So remember, very important that we plot correctly. So remember this column here, or this set of values here, is for the cumulative frequency curve on the y-axis, and these were the upper class boundaries for the x-axis. So first we're going to use plotting 0 against 0.5. So 0 against 0.5 would be, I think what I want to do here is use the pen, because the pen is a little bit brighter to emphasize the values. All right. So you usually use pencil, but I'm just going to use a pen to emphasize it a little bit. So 0 maps up with 0.5. Now I could have put another 0 here, all right? But I said that we could use 1, 0 for dual function. So this 0 here would be for the cumulative frequency axis, and this 0 here would be for the weight. So 0 would map up with 0.5, and this is 0, this is 1. So 0.5 would be essentially right here. All right, if you can see that. All right, the next one would be 8 mapping up with, let me just bring this over a little bit, 8 mapping up with 10.5. So remember now, if this is 0 and this is 10, we're going up by 2, 4, 6, 8. So 8 would be here, and that would map up with 2, 4, 6, 8, and 8 would map up with 10.5. Now 10.5 would be between 10 and 11. Remember, it's 10, 11, 12, 13, 14, 15. So 10.5 would be here, and that maps up with 8, so that would be right here. All right? So I hope you're seeing that. All right? You don't need to put extravagant marks and dots, just as long as you're seeing it. But because I want you to see it, I'm kind of putting a little extra mark in it. All right, the next one is 23 to 20.5. So 23, 20, 22, 24. So 23 will be between 22 and 24. So that's 23. And that is going to map, and you kind of carry this line across here, preferably with a straight edge. But for speed, I'm just going to use my, just use my hand and do that. So 23 matches up with 20.5. 20.5 is between 20 and 1. So I'm coming up here and I'm looking for 23, which should be around about here. All right. So 22 and 24, in between that is 23. So I have 1, 2, 3 points already generated. And the next one is 43 to 30.5. So 43, 40, 42, 44. 43 is in between 42 and 44. So that is 43, and that maps up with 30.5. And 30.5 on the x-axis would be between 30 and 31. So some of you would have done this already fine, but for those persons who didn't have the graph sheet, I'm just going through this again just to make sure that you're aware of what you should do. So 30.5 matches up with 43, which would be right here. All right. So far I have 4 points that I'm going to get the cumulative frequency curve drawn through. And the last one is 50. Remember I said it's important for you to stop here, because this is represent the top of the curve and this represents the total frequency. Never ever count above it. Just stop at the last value in the cumulative frequency column, which would have been 50. Which represents the sum of the frequency, which means the total number of packages. So never go beyond that when you're numbering the vertical axis or the y-axis. So 50, we already have a nice line for 50, and that is going to map up with 40.5. So 40.5 will be between 40 and 41. So that's here. So I'm just going to go up to 50, which is right here. And that would be your cumulative frequency curve. Now notice that when it comes up, there's a little curve here to end at the top. So that is synonymous with cumulative frequency curve. So I'm just going to do that. Again, I'm just going to use a pen, all right, to do that so it stands out a little bit. But you should use pencil all the time when you're drawing graphs. So I'm just going to come from here, get a nice smooth curve going. You don't have the issue of dealing with a paper tool this time around, but we have to prepare you, especially when you're moving on to university. All right, so that would be the cumulative frequency curve, and that would be as accurate as we can get it. Now the next thing we need to do is answer the 2 questions. Even though we did it rough sketch already, we're just going to do it here. So it says using. Now using means you have to use your graph. So using your graph, determine the median weight. Now remember, the median weight is coming from the quartile 2 value, which means that half of 50. Why? Because 50 is the top of the curve. So essentially we're going to come from 25, because half of 50 is 25. Remember, median means middle value. So I'm going to locate 25 here. So 20, 22, 24, 26. So 25 would be right in the middle there. So we're just going to come across using preferably a straight edge to the curve. You should use a straight edge, but for speed I'm just going to do this. And sometimes when we're doing this, you have a tendency to lean to one of these lines. You don't want to do that. All right, and just come down as best as you can. All right, so I'm just doing this for emphasis. So this is now 20, 21, 22, 23, 24, 25. So this is 20, 21. This will be 22, so it's 21.5. So it means then the median weight, right? The median weight would be 20, 21, 22, so 21.5 kilograms. So that's the median weight value that we got, 21.5 kilograms there. I think on a rough sketch we got 22 here, which means we weren't really far off, so not bad. So the median weight is 21.5 kilograms, and this is accurate, being that we're doing it on a graph sheet. Okay, so the next thing they ask us to find is the probability that a package chosen at random weighs at least 25 kilograms. Now, all we need to do is locate 25 kilograms on the x-axis, which would be, this is 20, 21, 22, 23, 24, 25, and there's a line there already, but just for emphasis, we're going up now, and we want to determine how many packages weigh 25 kilogram or more. So we're taking this across here, and remember it's probability, so it must be given as a fraction. So what we get here is this would be 20, 30, so this looks like 32. So if this is 32, remember we did a sketch, I think our value might have been a little bit different to the sketch. So this is 32 here, 30, 32, 34, 36, 34, right? So this is 32. Now, when you look at it, from here to here, 0 to 32 would be all of those packages that would weigh 25 kilograms or less. Because if any of these lines between the 32 and the 0 were taken across the curve and come down, they would be less than 25 kilograms. The maximum would actually be 25. So all of these between 50 and 32 now, if I were to take them across the curve and bring them down, you can see that they would be greater than 25. So they'll be between 25 and the 40.5 kilograms, right, that we have on the x-axis. So really and truly, by subtracting 32 from 50, we would get 18. So the probability, let me just write it here, the probability for that part of the question would be equal to the difference between 50 and 32, which is 18. 18 over 50. And when you have a fraction that you can be broken down, regardless of what is probability, please do that. So 2 into 18 goes 9, and 2 into 50 goes 25. So that would be the probability. I think when we did the rough sketch, we got 16 out of 25, which would be 8. 16 out of 50, which would be 8 out of 25. So it was pretty close in terms of accuracy compared to the sketch. All right. So I want you to look closely at these things here and get a feel of what the cumulative frequency curve is about in terms of you actually doing it on graph sheet. Now, one of the things that we could do to, in addition to the question, is find the interquartile range. Now remember, the interquartile range is equal to the quartile 3 value minus the quartile 1 value. So seeing that we have that, even though this wasn't a part of the original question, we're just going to do this. So what we need to find is the quartile 3 value, the quartile 1 value, and we'll find the difference to get the interquartile range. So we're just putting this additional piece of work there. Now, the quartile 3 value can be found by coming from quartile 3 down to the curve and get that value. So we're going to do this quickly, but remember that we had 50, yeah, and when you divide 50 by 4, 4 into 5 goes 1, remainder 1, and 4 into 10, 2, so 12.5. So quartile 1 would come from 12.5 to give us whatever that value is. Quartile 2, when you add 12.5 to 12.5, would give us 25. That is the same thing as the median value, and we already got that. So quartile 3, add another 12.5 to that, you get 37.5, and that is going to give us the quartile 3 value. So the two that we're interested in is this and this to use in the formula, right? Because we already got this as the median value with the 25. So we need to find this. So the first thing we need to find is 12.5 on here, which would be on the vertical axis. So this is 10, 0, 10, 12, 14. It's a little bit difficult because you have 10 and 12 and 14, 16, 18, 20. So CXC, if they gave you a paper 2, if you're doing a paper 2, CXC wouldn't give you a scale that it would be this difficult to find 12.5. But we're just going to make an estimate here. Whenever they give you a question, it's going to be very, very easy for you to find these values. But this exam is a little difficult. As I said before, this wasn't a part of the original question, so I'm just doing this now to show you how you'd find the interquartile range. So 12.5, so this is 10, 12, so a little bit above this would be 12.5. So I'm just going to take this across, just like this, and take this down. And that would be, this is 10, 11, 12, 13, 14. So the value that I got for quartile 1, the quartile 1 value would be 14 kilograms. Okay? So what I need to find now is quartile 3 value. Alright? So remember, we'd be using 37.5 now. And 37.5, this is 30, 32, 34, 36, 38. So 37.5 would be somewhere here. Alright, so I'm just going to take this across. Alright, now CXC, if you're doing a paper 2, CXC would give you some leeway in terms of error in accuracy or whatever. Alright, so don't get perturbed. If it's not fully accurate, try to get it accurate obviously, but if it's not fully accurate, CXC will still credit you with the marks. So here would be, this is 25, and remember 26, 27, 28, 29, 30, so this would be 27. So the quartile 3 value would be 27 kilograms. Why kilograms? Because we're dealing with weight on this axis, all right? So the interquartile value would be 27 kilograms minus 14 kilograms to give us 13 kilograms. That would be the interquartile range, 13 kilograms. And of course, to find the semi-interquartile range, we're simply dividing the interquartile range by 2. So that would be 13 divided by 2, which would give us 6.5 kilograms. Outside of this, gentlemen, there is nothing else that they would ask us to do. So you're going to review this video for me, and the next time we meet, we're going to be looking at another example before we move on to a different type of graph. So I hope you found this video insightful, and I'll see you guys on the next video.